So Bohr's model for hydrogen atom is based on the following postulates. Number 1. The electron in the hydrogen atom can move around the nucleus in a circular path of fixed radius and energy. These paths are called orbits or stationary states or allowed energy states. These orbits are arranged concentrically around the nucleus. So that indicates nucleus is present at the center of the atom and the electrons are revolving or move around the nucleus in a circular path of fixed radius and energy. And the second one is the energy of an electron in the orbit does not changes with time. So that indicates the energy of electron does not changes with respect to time. However, if the electron will move from the lower stationary state to the higher stationary state when energy is absorbed by the electron. So when energy is absorbed by the electron, what happened to that electron? It moves from lower level to the higher level. If energy is emitted by the electron, then it can move from the higher stationary state to the lower stationary state. And the third one, the frequency of radiation is absorbed or emitted when transition occurs between two states is differed by an energy delta E. So that indicates the energy absorbed or gained by the electron can be calculated using the formula delta E is equal to E2 minus E1. So always this change in energy should be proportional to the frequency of radiation. So that indicates the energy absorbed or emitted by the electron is always proportional to the frequency of radiation. The angular momentum of an electron. The angular momentum of an electron is quantized. So that indicates the angular momentum has a fixed quantity with respect to fixed energy state or fixed orbit. So that indicates in the first orbit the energy is fixed. In the second orbit the energy is fixed. So it can be expressed by the equation mvr is equal to n into h by 2 pi, where m is called as a mass of electron, where v is called as velocity of electron, and r is indicated as a radius of the orbit where the electron is revolving, and n is an integer where h is called as a Planck's constant. So according to this model, when we try to write the structure of an atom on the paper like this, so I am considering the carbon atom as example. So carbon atomic number is 6. So in that atom there are 6 electrons present and 6 protons as well as 6 neutrons are present. So the positive charge of the proton and the neutral charge of the neutron commonly called as a mass. So the total positive charge or the mass of the atom lies in a center. So this is called as a nucleus. And the negatively charged species called electrons, which are revolving around the nucleus in a fixed radius path and fixed energy. So carbon has 6 electrons. In that 6 electrons, 2 of the electrons are present in the first shell and 4 of the electrons are present in the second shell. So this is the final diagram of the atom according to Bohr's model, where this red dot indicates the nucleus and N1 is the first energy level or first stationary state, and 2 is the second stationary state, 3 is the third stationary state, 4 is the fourth energy level. If the electron releases some energy and it comes back from the fourth energy level to the third energy level. If the electron gains that energy, it may goes through the lower energy level to the higher energy level. Now going into the limitations of Bohr's atomic model. So the first one, it does not explain the spectra of atoms having more than one electron. So that indicates if atom consists of more number of electrons, that atomic spectra or that atom cannot be explained by this model. So the examples of single electron atoms are hydrogen, helium plus and lithium plus 2. So this model exclusively limited for these type of atoms only which has one electron. And the second one, this theory was also unable to explain the splitting nature of spectral lines in the presence of magnetic field. So this effect is known as Zeeman effect, or in the presence of electric field the effect is known as Stark effect. So the Zeeman and the Stark effects couldn't be explained by the Bohr's theory. So this effect is generally called as a splitting of spectral lines in the presence of magnetic field or electric field. And the third one, it could not explain the ability of atoms to form molecules by the chemical bond. So it couldn't explain the formation of bonds between the atoms to produce various number of molecules.